we're going to discuss exponential models and how to convert them into logarithmic form. So the first thing we're going to look at is an example of an equation for an exponential function. Now there's multiple equations that you will use with exponential functions, but this is the most basic equation. Y equals b to the x power. Now what makes an exponential function or model an exponential is that the exponent is the variable. So this first value right here, the a, is your starting value. The b is your growth or decay factor, so it's either going to go up or down based on if you're growing or decaying, and then x is your time. So with growth, this b value has to be greater than 1. So this is an example of an exponential growth equation. So 4 times 2 to the x power. So our growth factor would be 2, meaning it's going to double every time. So if we are going to graph this, we are starting at 4, and if we're doubling every time, so it would go from 4 to 8 to 16, and it would keep going like that. So your graph of a growth will look something like that, and it's going up from left to right. Now decay, if you have something that's a decay factor, that is a number between 0 and 1. So like 1/2, that means we're multiplying by 1/2 every time, so we're getting smaller. So for this one, if we start at 4, and then we take a half of that, that would be 2, and then 1, and then it would go down from there. And so you can see if you have an exponential decay, the graph is going down from left to right. Now this is exponential form, b to the e equals n, or ben form. And this is logarithmic form. So you can still see there's still the same b, n, and e, but just in different order. Now the b stands for the base, the e stands for the exponent, and the n stands for the number. So sometimes you will have to go back and forth and convert from exponential to log or log to exponential. So we're going to do that now. So this right now again is in our ben form, b e to the n. So if we were going to convert that, we have our log. Our b is right here, so 4. Our n comes next, so 16, and then that would equal 2. So that would be in logarithmic form. Now over here, when I'm going from this form to exponential, I do something called the lily pad method, where you start down here, go across the pond, which is across the equals, and then go to the other number, and it kind of forms like a lily pad. So that would be 2 to the third equals 8. Now what's nice with this form is you can check yourself. If I had this different, if I had 8 to the third equals 2, that's not mathematically correct, so I would know I did something wrong. So this right here, 2 to the third does equal 8, so you can see we did this in the correct order. Now here are some examples of when you have to actually solve or evaluate different logarithmic equations or expressions. So what we want to do for this, we're missing, if we have log form, we're missing our e, so our exponent. So I can rewrite these in exponential form and solve. So this, if I write it, use a lily pad method, this would be 5 to some power equals 125. So the answer would be 3, because 5 to the third equals 125, and that was my answer. Here, same thing. Whenever possible, I like to write in exponential form. So x to the 5th equals 32. So to solve, we would take the 5th root of both sides. So x would equal 2. And then here, this is what's known as a common log, because there's no base number. Whenever there's no base number, that number is automatically a 10. So it doesn't mean that it's not there, it's just a 10. That's called a common log. So again, if we were going to solve for the exponent of this, we can rewrite it. So it'd be 10 to some power equals 1,000. And so here, e would equal 3 as well.